Hi dear student, welcome to the classes. Now we'll go for the next continuation chapter in the D block element. The continuation concept in the D block element. What is that? I'll go for the trend in ionization energy. Trend in the ionization energy of the D block element. What is the trend? The trend means sometimes telling that how it increases or decreases along the groups and the period. Along the groups and along the period, how the ionization energy the changes, it varies along the groups and period. Now we will discuss today. Before going to that, first go for the one of the definition of that. What is mean by ionization energy? Now come to know that first ionization energy. What is mean by ionization energy? I think most of them are studied well. What is mean ionization energy is simply nothing but ionization. The meaning itself it is there in that. If for example ionize means we have to divide or we have to separate. Energy means separate ಮಾಡಕ್ಕೆ ಎಷ್ಟು ಎನರ್ಜಿ ಬೇಕು ಅಥವಾ ರಿಮೂವ್ ಮಾಡಕ್ಕೆ ಎಷ್ಟು ಎನರ್ಜಿ ಬೇಕು ಅದಕ್ಕೆ ಅಯನೈಸೇಷನ್. ಎದರೊಳಗಿದ್ರೆ ರಿಮೂವ್ ಮಾಡಬೇಕು ನಾವು ಏನು ರಿಮೂವ್ ಮಾಡಬೇಕು ದಟ್ ಈಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಓಕೆ, ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ದಿಸ್ ಈಸ್ ವಾಟ್ electrons orbital electron filling in the valence electron in the each orbital. For example, one electron is there in the outermost shell. Now this is what electron, this electron is having certain pores between the nucleus as well as the electron between this, the pores of the protons and electron. There will be some pores of attraction, right? We have to remove these pores. We have to make this electron to be free to remove. Therefore, now it is very easy now. Ionize means we have to remove the electron from this pores. We have to remove this electron from this the centripetal or the electrostatic pores. Therefore, what is mean by ionization energy? Ionization energy, now I will define. Ionization energy is defined as the amount of energy required. The amount of energy required to remove the isolated valence electron. You see here, this is valence electron. Is there here also electrons are there? But first ionization energy means first remove first outermost valence electron. Next, after removing valence electron, go for the next cell. Next cell. It is very difficult to remove first cell, second cell like this. First we have to remove outermost valence electron. Therefore, what is mean by ionization energy? Ionization energy means amount of energy required to remove the valence electrons of an isolated atom in a gaseous state. For example, these electrons we are removing, and this must and should be the atom in the gaseous state. For example, the sodium, a sodium atom, first electron, there are 2 electrons are here. Next it has 8 electrons are there here. Next 1 electron is there. Therefore, a sodium valence electron, valency, the first valency, the one first ionization energy ಅಂದ್ರೇನು, ಈ outermost electron ತೆಗೆಯಕ್ಕೆ ಎಷ್ಟು ಎನರ್ಜಿ ಬೇಕು, ಯಾಕೆ ಎನರ್ಜಿ ಬೇಕು, ಎರಡಕ್ಕೂ ನಡು ಸಮ್ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಇರ್ತದೆ. ಈ ಫೋರ್ಸ್ ಅನ್ನು ನಾವು ರಿಮೂವ್ ಮಾಡ್ಬೇಕು. ಇದನ್ನ ರಿಮೂವ್ ಮಾಡ್ಬೇಕಂತ ಸಮ್ ಎನರ್ಜಿ ಕೊಟ್ಟರೆ ಎಲೆಕ್ಟ್ರಾನ್ ಹೊರಗಡೆ ಬರ್ತದೆ. Therefore, amount of energy required to remove the valence electron of an isolated atom in gaseous state must and should be this sodium in gaseous state. Whenever we remove the electrons or adding electron, the atoms or molecule must and should be in gaseous state. Okay, I hope everyone can understand this. After this ionization energy, we learn that how this ionization energy varies along the periodic table. For example, this is what left to right and top to bottom. How it varies? You see here, always this ionization energy from left to right increases. Left to right ionization energy increases, and top to bottom it will be decreases. Why it is like this? That's very important. You see here the ionization energy from left to right increases and right to top to bottom decreases. Left to right and it will be increases. How? You see it. Already we know that the size of the atom decreases from left to right. Left to right, the size of the atom will be decreases. That's right. We know this. And top to bottom size will be increases. Here, for example, the electrons are there here. Here electrons are there, and here also the valence electrons are there in the outermost shell. Here electrons are there. Here means the atoms, the size increases means the force of attraction between the atoms and electrons and protons. There will be more electrostatic force of attraction compared to this. Here the atom is very small. The electron, proton, they are very near. They are very near. ಈಗ ನೋಡ್ರಿ, ಈಗ ಎರಡು ಪ್ರೋಟಾನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅದಾವ ಅಂತ ತಿಳ್ಕೊರಿ. ಎರಡು ಸನೇತ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಭಾಳ ಇರ್ತವೆ. ಸ್ವಲ್ಪ ದೂರ ಇದ್ರೆ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ರಿಪಲ್ಷನ್ ಕಡಿಮೆ ಇರ್ತವೆ. ಹೆಂಗ ಇದು ದೂರ ಹೋಗೈತಿ ಹಂಗಿದ್ರ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಕಡಿಮೆ ಆಕತಿ. ಹೆಂಗಿದ್ರ ಸನೆ ಬರ್ತೈತಿ ಹಂಗೆ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಹೆಚ್ಚಾಕ. ಈ ಅಟಮ್ ಸಣ್ಣದೈತಿ ಅಂದ್ರೆ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ವಿಲ್ ಬಿ ಮೋರ್. ಇಫ್ ಅಟಮ್ is larger means the force of attraction will be less. Okay, you see here the atomic the ionization energy from left to right increases, from top to bottom increases. We see here if atoms are very large. For example, this is proton, they are electron. This is nucleus like this. This is nucleus and this is electron. If atom is larger means there will be some force of attraction less. If atoms are bigger, there will be very less the force of attraction. They are very less. If atom come to closer and closer, the force of attraction will be increases. Therefore, we have to require more energy. ನೋಡ್ರಿ, ಇವೆರಡಕ್ಕೂ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಮೋರ್ ಐತಂದ್ರೆ ಇವೆರಡಕ್ಕೂ ದೂರ ಮಾಡ್ಬೇಕಂದ್ರೆ ಎನರ್ಜಿ ಭಾಳ ಬೇಕು. Therefore, we have to require more energy to separate these two. Yes, right. Therefore, atom size ಹೆಂಗ್ ಕಡಿಮೆ ಆಕೈತಿ ಹಂಗೆ ಎನರ್ಜಿ ಭಾಳ ಬೇಕು ಇವೆರಡಕ್ಕೂ ಸಪರೇಟ್ ಮಾಡ್ಬೇಕಂದ್ರೆ. ಇವೆರಡಕ್ಕೂ ಫೋರ್ಸ್ ಭಾಳ ಇತ್ತಂದ್ರೆ ಎನರ್ಜಿ ಭಾಳ ಬೇಕು. ನಾವು ಎರಡಕ್ಕೂ ಎನರ್ಜಿ ಭಾಳ ಕೊಟ್ಟು ಎರಡಕ್ಕೂ ದೂರ ಮಾಡ್ಬೇಕು. ಹೆಂಗೆ ಅಟಮ್ ದೊಡ್ಡದಿತ್ತು ಬೇಗನೆ ಬಾಂಡ್ ಕಟ್ ಮಾಡಿ ಬೇಗ ಎಲೆಕ್ಟ್ರಾನ್ ತೊಗೊಂಡ್ಬಿಡ್ಬೋದು ಹೊರಗಡೆ. ಹೆಂಗ ಸೈಜ್, therefore the size of the atom, if their size will be decreases, the force of attraction more, therefore it is very difficult to remove the outermost electron. Here atoms is very bigger, the force of attraction, for example, the force of attraction will be less, therefore this bond breaks very easily. It's like I am explaining like this. Therefore electrons remove easily, therefore we are getting easily electron. Therefore size of the atom increases, the force of attraction is less, therefore little energy is sufficient to get the valence electron. Therefore left to right increases, top to bottom decreases. Okay, now from seeing in your PUC secondary the syllabus they are given, and also one more thing I will tell you. For example, metal, in this metal is there here. In metal we are removing first one electron, therefore one electron removing means it is like this. Metal removing one electron, it gives us to positive charge, and this is called as first ionization energy. The first electron removing is called as first ionization. Next again this already M plus is there, we are removing one more electron in this M plus and plus plus, therefore again this one second ionization energy. This one also write as M2 plus, no problem. M plus means M2 plus. Here M2 plus we are removing again one more charge means M3 plus, therefore electron removing, therefore it is called as third ionization energy. Like this the in continuation removing of electron. Here the first ionization energy is very less than that of second ionization energy, is very less than that of third ionization energy, like this continuation. Therefore always the higher ionization energy is very greater compared to first ionization. How it is I will tell you. Therefore first ionization energy is less than second, third, like this. You see here, this is what our sodium, the first valence electron, next here first 2 electrons are there, here next 8 electrons are there, here 8 electrons are there, here only 1 electron. Here this electron first ionization energy means sodium is going to convert sodium plus, removing one electron. This is outermost electron, therefore this is first ionization energy. First ionization energy. Next you see here, this sodium plus is there, means we have removed outermost electron. This one, outermost valence electron is gone. Next again we are removing one more electron in this. If you are removing one more electron, means it is going to Na2 plus one electron remaining, means it is second ionization energy. Where we are removing this electron, one electron we are removing, means this is already completely filled. It is completely filled means we have to require more energy to remove this electron, because it is already stable. Therefore we are requiring more energy to remove the completely filled shell. Therefore second ionization energy is more. Next ionization energy also more. Therefore like this, the first ionization energy is less than second, like this it will be increases the first, second, third ionization energy. Okay, now we are going for the your D block element. For D block elements, for scandium to zinc, the ionization energy will be, what happens, increases. Next, middle manganese, here zinc, this is 3d10 and this is 3d5. Here therefore these 3d10 3d5 is there, they are completely filled valence electron, therefore they are having exceptionally higher ionization energy. You see here, now we go for seeing this. You see your ncrt book. In this ncrt book they are given the ionization energy calculation. They are given this ionization energy. The ionization energy of first, you see continuously what happens, it is increasing, continuously first increasing. They are given first ionization energy, second ionization energy, third ionization energy. First ionization energy, scandium, titanium, vanadium, chromium is here 603, 656, 650, 653, 712, 762, 756, like this. But zinc, it has 906. This is first ionization energy, dear student. Next they are given in bottom in the other category. First is second, they are given means second Roman and 2 put. Second ionization, therefore from top, first ionization energy, second ionization increases from top to bottom because they are first, second, third ionization. Again you see here, this is what ionization energy increases. Yes, right. Therefore you observe these value. From this they are not, you don't mug any these value, but they are given for you for the understanding, for the sake of understanding they are given the ionization. You see here, and one thing you observed here, a third ionization energy of Mn3 plus is around 3260, but Fe3 plus is 962. Why it is like this? Why it is like this? You see here, Fe2 plus Mn2 plus, Mn2 plus and Mn3, Fe2 plus here, Fe2 to Fe3 ಆಗಬೇಕು, Mn2 to Mn3 ಆಗಬೇಕು. Fe2 to Fe3 ಆಗಬೇಕಂದ್ರೆ you see here Fe2 outermost, this Mn2, this is higher and it is very less. That the one I am explaining in this series only. There Mn3 plus they are given 3260, 2962 they are given, but it is continuously increasing, but it is decreasing. Why it is decreasing, I will tell you. This Fe2 to Fe3 ಆಗಬೇಕು ನೋಡ್ರಿ, Fe2 to Fe3 ಆಗಬೇಕು. ಇದು ಸೆಕೆಂಡ್ ionization energy, ಥರ್ಡ್ ionization energy ಬಂದಿದೆ, ಹೌದಾ? Fe2 ಎಲೆಕ್ಟ್ರಾನ್ ಕಾನ್ಫಿಗರೇಷನ್ ಏನು, 3d6 means 4:3d6. Fe3 ಆಗಬೇಕಂದ್ರೆ 4:3d5 means here 6 electrons are there, it is removing one electron, it is giving one electron easily and it attain 3d5 stable structure, therefore it gives electron easily, therefore ionization energy decreases. Like this Mn, what happens here, Mn, here Mn2 to Mn3, Mn2 plus Mn2 plus to Mn3 plus, Mn2 plus to Mn3 plus. Here Mn2 plus means 4:3d5. One electron remove ಮಾಡಬೇಕಂದ್ರೆ 3d5 ಅಂತ ಇದು ಏನಾಗಬೇಕು, ಇದು 4:3d4 ಆಗಬೇಕು. Therefore this completely half filled ಐತಿ, ಇದರೊಳಗೆ electron ತೆಗಿಬೇಕಂದ್ರೆ higher energy. Therefore This is higher energy. Next it is lower energy because it attains stable structure. Next, continue. See here the values. Zinc, the first the zinc. The zinc family means zinc, cadmium, mercury. They are always, you see here, outermost 906, 1952, and 3823. The zinc is always almost they are higher energy because they completely filled electronic configuration. They are 3D10, 4D10, 5D10. And Mn, the 3 plus more stable ionization energy to Mn2 plus. Mn2 plus to Mn3 ಬರಬೇಕಂದ್ರೆ more stable ನಿಂತರ less stable ಬರಬೇಕು ಅದು. ಅದಕ್ಕೆ ಅಂತ ಹೇಳಿ ಅಲ್ಲಿ ಏನಾಗ್ತದೆ high ionization energy. Like this same Fe2 plus to Fe3 ಬರಬೇಕಂದ್ರೆ Fe2 completely stable ಇರುತ್ತೆ, Fe3 plus ಬರಬೇಕು high energy. Therefore it is also required very less energy to attain the stability. Okay, if you like, this is what very simple, dear students. Whenever you know the basic, they are very easy. You see, don't skip any videos whenever you are seeing the videos. Nowadays I am hearing more and more online classes. How much it is effective I don't know, but I am also doing these online classes, but most of them either they are taking use or not, I don't know. I am not at all checking, it is not possible to check. Okay, if you like, please give the comment, and don't waste the time, utilize the time very well. Okay, it is very precious time. Learn everything it's a good time to learn. Okay, please, if you like my videos, please share and subscribe my channel. Thank you for watching my videos.